Hello everyone, this is Om Godge and today I'll be solving lab 7. So the first question was Wordle. This is made by me. So I'll just explain the question. So there's an array of strings that you are given, and there is a partial word that you are given. You have to find the word from this array that matches this partial word. So to do this, you will simply uh, um, let's say you have PLE and you're trying to match it with banana first. So the first thing is, when you're trying to find a match, these two words should have the same size. If they don't have the same size, this partial word can never represent this word, right? It's common sense. You can figure this out on your own. Okay, so since this is of length 5, you also need a word that is of length 5. So let's say that you have some other word, lychee, which is also length 5. Okay, so now how do you find whether this partial word fits this word? So whenever you have an underscore, you cannot really match anything because this can represent any letter. So you skip an underscore, you just continue on an underscore. Whenever you don't have an underscore, you should make sure that this letter and this letter matches, which in this case it doesn't. Here we have an I and here there's a P, so they don't match, so they can never be the same word. So you will break out of the loop and check the next word. So lychee this cannot be represented by lychee, so you will try another word. So oops, then let's say you try apple. Over here P also matches and L also matches, so this is the right word that you found, and apple will be the answer for this. So let's write the code for this now. Since you guys have learned vectors, I'll use vectors in my solution. Simple CPP. Date 7th March 25. Okay. And main vector string candidates. This will be of size n. Then you have an int n. You take n as input, and you have a string partial word. Then for int I equals 0, I less than plus cn candidates I, cn partial word. Okay, taking the array as input. Sorry. So when you create a vector of size n, you use parentheses instead of square brackets. So just make sure you remember that. Okay. Then you take in the partial word. Then for int I equals 0, I less than n, I plus plus, iterating over each candidate. You also create a bool called is matching, and if not is matching, I need to print not possible. Fine. Okay, now you will see if okay, you have to set is matching to true. My bad. So before you check every candidate, you assume that it matches, and then you find a mismatch. So you need one letter to mismatch. If you find a mismatch, you will set is matching to false. Okay, fine. So now you check if partial word dot length is not equal to candidates I dot length, then is matching is false because this can never match it, and you continue. You check the next candidate in the list. Okay, then you iterate over all the letters. J less than partial word dot length J plus plus if partial word J equals, then you can continue. If not equal to candidates IJ, then you have found a mismatch over here, so you will set is matching to false, and you will break out of this inner loop. This is iterating over all letters one by one. Okay, and then if you have if is matching, if you found a match, then you just print out candidates I, and then you will break out of this because you don't need to check any other letters, that because they have told that there will always be one matching candidate. So yeah, that's it. Let's check if it's working. Not possible. Okay, yeah. So that was it for this question. If match found, print candidate and breakout. If no match found, print not possible. Okay. Okay, now on to the second question. So you are given a jumbled word and a vector of possible words. So you need to check which particular word from here matches with this word here. So yeah, that was it for this question. You need to find which of these matches these ones. Okay, so to solve this question, this should be NA. To solve this question, the first method is to keep a frequency array and just find the frequencies one by one and match the frequency arrays of every word and see which one matches. And the other one, so this will be slightly tedious, the other one is to compare sums and products directly. So that is what I'll be doing in my solution. So okay, let's just take this. Okay, and then I have this word. Alright, so for each of these words, right, I'll create a vector called sums, which will store sum of ASCII values of all characters in a word. Okay, and Similarly, I'll create prods, which will be the product of ASCII values of all in each word rather. So essentially sums I gives you the sum, gives you the sum of ASCII of let's take one over here. So sum of ASCII of banana, and prods 1 would give you the product of ASCII of banana, and then you do the same for this guy. So for this guy as well, you find a sum and prod and compare this with each sum I and prod I. And then whenever you find a match, so wherever you find that sum is equal to sum I and prod is equal to prod I, that is the word that you're looking for, and you can print out that word directly. If you don't find such a match, then you'll have to print a null in the question. Okay, so I'll show you the solution now. Okay, so I have used vectors in my solution because you have learned vectors now. So okay, so this will be array vector of possible words, and then this is vectors to store sums and prods initialized correctly. So all the sums will be 0 at the start. So before filling them, you will have all of these. You will have all of these as zeros. So you'll have 0, 0, 0, 0, 1, 2, 3, 4, 5, 6. Okay, yep. And then similarly, even this guy will be all ones. So it will be 1, 1, 1, 1, 1, 1. The reason why this is ones is because you can multiply numbers into the 1 is the identity of multiplication and 0 is the identity of addition. That's why these are initialized by zeros and these are initialized by ones. Okay, so this is how you do it for vectors. Alright, then you input each possible word and compute the sum. Okay, never mind, I'll write it inside. Compute the sum and prod for this word. So you see in pos words I, and then you iterate over each character. Okay, so iterate pos words I and compute the sum and prod for this word. So you just do plus equals pos words ij and star equals pos words ij, and the sum and product for the word I will be calculated here. So like this, every word's sum and product will be calculated one by one. Then you have a jumbled word, which is this word over here, and then this is to print null if no match is found. Then you take jumbled word as input. This stores sum and prod of jumbled word. Then calculate sum j and prod j. So you just do the same thing that you did over here for every word, and then iterate over each pos word and check if sums and prods match up. So you iterate over each word and you check if these two are equal, then you have found a word. So you print the possible word and you set found to true, and then you break because you don't need to check other words. And if you've not found, then you'll keep on checking other words one by one. At the end, if you don't find any word, then you'll print null at the end. Yep, that's all for this question. The reason why I have taken long here is because in that question you might have seen that prod might become negative if you use ints over here, because the products could become very large. That's why I've used long here and here as well. You don't need longs for the sum, but I just kept it together. That's why I have used long. Yep, that was all for this question. Okay, now on to the third question. Newly enrolled students. So in this you have two lists of students, A and B, and you want to check you want to find those students such that they are present in the list B but they are not in the list A. So is there an example? Okay, never mind. Let's say that B is these they are integers, so I'll construct let's say this is 1 2 3 4 5 and A is 3 4. So 1 2 and 5 are the new students and you need to find those. So what you'll do is, for every one of these you will check whether they are existing inside A or not. So simply just iterate over each element over here in B and then check whether they are present in A or not. If they are present in A, then you don't need to do anything. If they are not present in A, then you have to print out this particular roll number. It's just a simple double loop. There's not much to think of in this. So yeah, I'll just show you the code then. Okay, so this I've created a custom input function for inputting the array. So this function, it just fills up at the array. The reason why I've written this function is because it will minimize your code. Instead of writing a for loop 2 times to fill up A and B, you can just call this function twice and it will fill your array correctly. You pass it by reference. So this is how you pass a vector by reference to a function and it will fill the vector correctly. Okay, so then this is vector A and this is vector B. I don't think so these comments are required. You fill in B and fill in A. No new student is required to print no if no new student found. So this is set to true first, and as soon as you find a new student you will set it to false. That's all it does. If there is no new student, then you just print no new student at the end if this remains true after this whole thing is done. Okay, then you iterate over each roll number in B. This did you find this BI in A? Iterate over each roll number in A. If BI found in A, set found to true and break. If BI not found in A, new roll number, so print BI and set no new student to false. No new student found. Print no new student. Yep, that was it for this question. This was an easy question, so not much to explain. The fourth question was XOR Students. So you are given two lists of roll numbers, one for CS101 and one for MA110, and you need to find the numbers that appear in only one of the lists. They cannot appear in both, or they cannot not appear in anything. So yeah, they are told to print it like CS101 first and then MA110. So it's pretty simple, like just iterate over each of these roll numbers and check whether they appear in this list or not. If they don't appear, then you simply print it out, and then do the same for MA110 as well. Iterate over each of these, and if they don't appear in CS101, then you just print the roll number out, and that's all. So here is the code for it. So this is a similar input function as it was over here, just that now it's storing strings instead of integers. Okay, so you take A as input from the user, and then you have CS101 and MA110 as vector of strings, and then you take them as input. Okay, then as input from the user. Fine. Iterate over each in CS101. Check whether it appears in MA110. If it doesn't, print it out. Similarly over here, you iterate over each roll number in MA110, and then you check whether it appears in CS101. If it doesn't, print it out. Yeah, that was it for this question. Yeah. Okay, now the fifth question was using structs to solve. So you should have figured out how to create structs in this. Okay, I'll give some more time to this question. So in this question, you have to create a struct called rational. So okay, wait. Alright, fine. So you have a struct called rational having two integer data members called numerator and denominator. So I have just made them num and din for shorthand. Yep. So you have two of these data members. On only creating this structures users, you need to support operations. So, alright, fine. I'll take up these names. Add rat. Subrat. And motherrat. Okay. So you need to make these three functions. Each take two rationals as argument, and you return a rational. And you have to make sure that the rational returned is in its simplest form. Okay. So let's have a look at the add rat function. So in add rat, you take two rationals by reference. So you don't really need to take them as reference. I just took them as reference to reduce the amount of memory that is used. Okay. Then I create a new rational inside called z, and then I said z dot num equals x dot num into y. So wait. Let's say you have one. Okay, I'll have to type this. Let's say you have 1 by 2 and you are trying to add 3 by 4 to this. So you will multiply this over here and this over here to get 4 plus 6 divided by 8. Now this is what I'm doing, and then you will get 10 by 4. You convert this to simplest form and then you will get 5 by 2. This is how you do addition for rational numbers. So that is what I've done over here. I multiplied the numerator with this with this, and then I multiplied this with this for the numerator. And then for the denominator is just the multiplication of both the denominators. And then so there is this method called simplest form. I'll explain that later on, but for now I just convert z to its simplest form and then I return z. That is what the add rat function does. Similarly for subrat, it is similar to add rat, it's just that there is a minus sign over here. So you do x dot the numerator of x multiplied by denominator of y minus numerator of y divided by multiplied by denominator of x, and the denominator stays the same, and you just bring it down to its simplest form and you return it. And the motherrat is simple. You just multiply the numerators and denominators, you convert it to the simplest form, and you return z. So those are all the three functions over here. So now to get the simplest form, this function is implemented inside rational itself. So inside the rational structure, you create a function called simplest form, which finds the GCD of the numerator and denominator. Now this GCD function you've seen before, only written in a recursive form now. This is the Euclid's algorithm to find GCD. Okay. Fine. So you find the GCD of the numerator and denominator, and you divide numerator and denominator by the GCD to get the simplest form of this rational number. That is the simplest form function. Then the main function is pretty easy. You just have a, b, c, d. You take them as input, then you create two rationals, a by b and c by d, and then you just print out the numerator and denominator of add rat, subrat, and motherrat. There is actually another thing you can do. is you can just create a print function over here which just prints out numerator and denominator like this, and then instead of doing all of this, you can just call print on this, then you can call print on this, and on this. Okay, let's see if this works. 1 1 2 3 1 10 2 3. Okay, fine, this works. So yeah, so this is something that you should learn, that you can create functions inside the structure and you can call them with a dot. These are called methods. So simplest form and print are methods of the struct rational, and these are the data members. So the variables inside a struct are called data members and the functions are called methods. Yeah, that was it for this question. The sixth question is operate on time. So in this question, similar to the previous one, you have to create a struct called time. So you might be getting errors using this exact name. That's why I've used all caps time. So you create this struct which has two fields, hours and minutes. So they are integers. So I have h and m representing hours and minutes. Then similar to the previous question, I have created a print method which just prints h hours, m minutes. So the output format is this way, and that's how it prints the struct. Okay, yeah. Then you have to make two functions called add to add and subtract the structs. So add time is pretty simple. You take two structs t1 and t2. Okay, wait. Alright, fine. So you take two structs t1 and t2, and then you create a new struct t. You add the hours and minutes up, and if the minutes are greater than 60, then you just add it inside hours and you subtract 60 from minutes, and then you return this t. This part actually can be done inside time itself. So as I had done simplify, okay, rather than doing this, you can do if m is greater than 60 and this. Okay, so you could do this directly, and then you could have t dot simplify over here. Similarly over here, okay, never mind, this will not work. Fine, because you are subtracting over here, that's why. Okay, anyways, so you do this, and in subtract time, so there's a small catch. You have to check which one is the bigger one, so which is the bigger time out of both of them, and put that in. So I've assumed that the t1 is the time bigger in both of them. Instead of doing the swap, what you can do is time temp equals t1, t1 equals t2, and t2 equals temp. This will do the same thing. The swap function just makes it smaller. It is a function in the standard library. So okay, fine. Then you have you subtract the hours and the minutes. If the minutes go less than 0, then you subtract 1 hour and you add 60 minutes in 2 minutes, and then you return t. Okay, then inside main you just have t1 and t2. You take them as input, and then you print out add time t1 t2 and subtime t1 t2. Yep, that was it for this question. Okay, the next question is find the number. So you're given an array and a number x, and you have to search this number in the array. If you find it, you need to return the positions in the sorted order, otherwise you print -1. So okay, so here is the code for it. You have an integer n, you take it as input. Then you have a vector a, but as they have said that there's an array, so I'm using a vector to store it. You take a as input from the user, and then there's an x. Then I create a vector b which will store the positions of x, like wherever x occurs, and I don't specify a size at the start, and then wherever so I iterate over each element in a. If ai is equal to x, I add I to b directly. So b will store b. Okay, wait, I'll write it over here. B stores the positions of x in a. Then if b is empty, you print -1, otherwise okay, fine, print the positions of x in a. So yep, that's pretty much it. The only thing you have to do is just store all these positions and then just check that there are positions available. So if there is a position found over here, then b dot size will be greater than 0, it will not be 0. So that's how this works, and then you simply print it out if there are some positions over there. Yeah, that was pretty much this question. Okay, so now the next question is missing number. You are given some numbers between 1 to n, and you have to figure out which numbers are not given. So in this question, k should have been given. Like, without giving k, taking inputs is slightly complicated. So yeah, you would have been given k in the question ideally. So you would have been given n and k. So here it would be 2, and here it would be 1 2 3 4 5 6 7. That would be 3 3. So this is how the test cases should have been. But anyways, we'll assume that k is not given, and then write the solution. Okay, so the idea is as follows. Okay, so we'll have an array of booleans which goes from which has size of n. So a of I represents whether I appeared in the input. Okay, so we just check if ai is 0, then we print I, otherwise we keep on checking the other numbers. So that's it. That's what you have to do in this question. The tricky part was to take the input. So for that you can do this. You can write while c in L. So when you do while c in some variable, this will return. Okay, I'll remove the while part. If you do c in variable, This gives you a value of true if input is still being given, and it gives you false if input has ended. Okay, this is pretty easy to understand. The thing is, when does the input end? How do you end the input? So to end the input, you need to use Control D, that or Command plus D if you're on Mac. So yeah, I don't think I should explain this more, but okay, I'll give you a small example. Okay, so I'll remove these for now. Fine. Yeah, so as I was saying, you can put the input inside an input inside a file, and so as you do a dot out and then you type it out manually like 135, and then you have to do Control D. Instead of doing this, what you can do is just do a dot out and then do less than in.txt, because the test case is stored inside this file. So the end of file is denoted is the same as pressing Control D. This is why it is interpreted as the end of input, and that's why this guy returns false, and then you no longer read things in and you exit this while loop. So yeah, that's the reason why you have to hit Control D when you're manually typing it out. Like when you do this, you have to hit Control D manually, but we don't run test cases this way. We instead store them inside an input inside text files, and then we just do less than input.txt. Like Bodhi tree and any system that is checking your code will usually do this. So that's why you can use this fact and write your code. That's why this while loop works. Okay, so in this while loop I just see in L, I take the number L and I do a of L minus 1 as 1. The reason why I've done L minus 1 is because so you can choose to do a of L as well, but then you will require, so if you have a of n, the indexes are from 0 to n minus 1. If you want to do a of L directly, a of L equals 1, so you will need index n as well. So you'll have to make an array slash vector of size n plus 1. So if you have a of n plus 1, so what I'm saying is, if you have int a of n plus 1 and int a of n, then over here the indexes will range from 0 to n. And now you can do a of L equals 1 over here. So what I'm saying is, if I do n plus 1 over here, then I can do a of L, and then I can just do this. This will work. But and the thing is, if you do this, the 0th one, like A0, will be wasted memory, as you would never access it. So that's why I've done a of L minus 1. Yep. So I wanted to write good code and I want you all to write good code. That's why I've done a of L minus 1. This doesn't waste any memory at all. So you have numbers from 0 to N minus 1. So I just map L to L minus 1 to use that range. And then afterwards I check, I iterate over all the, I iterate over each element until end of input. If number missing, print it, and then at the end you just print an endl. Yep, that was it for this question. Okay. Ninth question now, quadruples. So you are given an array of integers and need to find a quadruple of integers such that a square plus b square equals c square plus d square. Okay, so one way of doing it is to make an array and take inputs, input the array, and then just okay, so you have your array like this. Okay, you need to pick quadruples and they should not repeat, so you cannot have a b c d and a c b d as well. There should be some order in this. Like for this example, you cannot have 1 1 1 1 4 times, or wait, how many, 16 times or whatever. 1 1 1 1 will just appear once, so there is some ordering. So the first loop over here, it goes from 0 to n. The second loop goes from I plus 1 to n. The third goes from j plus 1 to n. The fourth goes from k plus 1 to n. So essentially what you're doing is, let's say I was here, this is I, then j would be selected from here, let's say j was this, then k would be selected from here. If k was this, then L would be this. So you always maintain this ordering, that I less than equal to less than j less than k less than L. And this ordering will make sure that you select one quadruple only once. If you start every single one of them from 0, then you will find that the same quadruple is appearing multiple times. So if I run this and I put this as input, it gives me multiple answers and some of them are wrong as well. So it's selecting 8 twice and 8 is only there once in the loop. That's the reason why you do you keep an order, and this also avoids repetition of the same indices. So 8 is getting repeated over here, right? So yeah, that's the reason why this is done. And then over here you just check if ai square plus aj square equals ak square plus al square. If that is the case, then this is a valid quadruple, and then you print the 4 numbers with commas in between and brackets at the start. Select 4 ordered indices and check if they are a valid quadruple. Yep, that was all for this question. Fine, I'll just put 7th for now. Okay.
والعود دندن دنلي والطبل طب طب طبني طب 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 طب